Hello again, welcome to the Chapter 4 review video. We're going to go through quite a few different calculator techniques in this video, so this chapter really gets a good work out of the TI-84. So again, if you have it handy, follow along with me and take some notes as you go. Let's begin. Number 1, true or false, the number of kittens in a litter is an example of a discrete random variable. Random variables essentially take on one of two forms. They are either discrete or they are continuous. How we tell the difference is essentially how those values are recorded. Discrete random variables take on a countable number. They are essentially integer values. So 0, 1, 2, 3, so on and so forth. Fractional values in between those integers don't really make sense in a discrete random variable. Continuous random variables can take on any value within an interval. So for instance, time is a continuous random variable. You could study for exactly 1 hour, 13 minutes, and 24 seconds, right? Those are fractional parts of time. So anywhere within two endpoints of an interval is how we're defining a continuous random variable. Discrete random variables, again, fractional components don't really make sense. So for instance, you can't have 1.5 kittens, right? That sounds kind of gruesome. So the number of kittens in a litter is a discrete random variable. You have exactly 1, exactly 2, exactly 3, so on and so forth. So we would say that this is true. Number 2, determine the probability distribution's missing probability value. Okay, well, one of the properties of a probability distribution is that the sum of the probabilities should be equal to 1, right? The sum of all these values should be 1. So if I add up 0.25, 0.3, and 0.1, we would get 0.65. So that means that my missing value must be 1 minus 0.65, or 0.35. D. Number 3, let X represent the number of televisions in a household. Find the mean. Okay, well, the mean of a probability distribution is defined to be the sum of the values of the probability distribution times their probabilities. So as a formula, the mean looks something like this. The sum of the products of the values times the probabilities of those values. So in this case, we're going to be adding up the products of 0 times 0.05, 1 times 0.2, 2 times 0.45, and 3 times 0.3. So one way to go about this using the calculator is to put your X values in a list and then put your probabilities in a list, and then we can manipulate those to find things like the mean and the standard deviation. So let's go ahead and practice doing that. Obviously I could do this by hand and just type it in, but if you had a list of maybe 15 or 20 things to do, you probably wouldn't want to do it by hand. So just for practice, we're going to put these in to our calculator. We're going to hit the Stat button, we're going to hit Edit, and in list 1 we're going to type in 0, 1, 2, and 3. And in list 2, we're going to type in 0.05, 0.2, 0.45, and 0.3. And those are going to be our X values and our probabilities. So I'm just going to make a note here that I put this in L1 and I put the probabilities in L2. Okay, so in order to complete this calculation that I have in red here, the mean being the sum of the products of those two lists, the first thing I want to do is multiply L1 by L2, right? Because the X's are in L1, the probabilities are in L2, so I want to multiply those two lists together. Second 1 gives me L1 times second 2 gives me L2, and then I essentially want to sum up that list. So I could either do that by hand, just visually, or I could save the list I just came up with, the 0.2, 0.9, 0.9. I could save that list by hitting the store button, and I'm going to save it in second 3. So the list that I just came up with, the product of L1 and L2, I'm saving it with the store button in L3. Okay. Now all I have to do is do one variable statistics on L3, and that will sum up that list. So the stat button, scroll over to calc, one variable stats, and then this time I want to sum up the stuff in list 3. So I don't just want to hit enter here, I want to make sure that I'm pulling the data from the list in L3. So one variable stats on L3, and I'm looking for the summation symbol, the sum of the stuff in L3. The sum there is going to be 2. So that's going to be our mean. Number 3, the answer there is A. Number 4, let X represent the number of televisions in a household. Find the standard deviation. Okay, now in this one, we're still working with the probability distribution, and our formula for standard deviation is very simple. It is the square root of the sum of the deviation, so data values minus the mean, that's the deviation. We're going to do that for every value of X. We're going to square those deviations and multiply them by their probabilities. So this is, again, a sum of products. The two things being multiplied together here are the deviation squared and the probabilities. We're going to sum all that stuff up, and then we're going to take the square root of it. Again, this is a very small data set. You could do this by hand. It probably wouldn't be a very tough calculation to do, but I'm going to let the calculator do the heavy lifting for me. So I'm going to quit out of here and clear my command window, and we're going to go through this again. From the previous problem, let's scroll back up there real quick. From the previous problem, I know that the mean is 2, right? It's the same data set about televisions in a household. So I already know here that mu is 2. That's the mean. So this is what I'm subtracting from every value in the data set. X, all of these X values here, I want to subtract 2 from each one of those values. Okay, so again, let's let the calculator do this. The X values I know are already in L1, right? So I'm going to hit second 1, that's L1, and I'm going to subtract 2 from all of those values. Those are the deviations. Okay, now I want to square all of those values. So let's overwrite the data set that's in L3. Let's go ahead and store these guys, the -1 or -2, -1, 0, and 1. Let's store that list in L3. Store second 3. So let's store that list in L3. And let's square it. Second 3 squared. So there's the deviation squared. That's what I have here highlighted in yellow. Those are the squared deviations. Now I want to multiply those squared deviations by the probabilities. Now we'll remember that we put these probabilities in L2. Remember from the problem that we just did here. Let's scroll up again. Oops. We already put this stuff in L2, so I know the probabilities are there. So squared deviations are in L3. I'm going to multiply them by their probabilities in L2. So multiply the squared deviations. We're just going to hit the multiplication button. That's going to take our answer, and we're going to multiply it by second 2, the stuff in L2. Okay, now this list is the list that I want to sum up. So I'm going to store it again. Store in second 4, store it in L4. And now I want to sum up that stuff. Right, here's what I'm asking it to do next. I want to sum up the product of the squared deviations and the probabilities. I'm going to sum that up by doing stat, scroll over to calc, one variable stats on L4. Whoops. I did not hit that correctly. Stat, calc, one variable stats not on 4, second 4, L4. There we go. Okay, now the sum of the products of the squared deviations and the probabilities is right here. The sum of the stuff of in the list L4 is 0.7. So our standard deviation here is going to be the square root of 0.7, which is what? Second square root of 0.7 is approximately 0.83666000265. So that is going to round to be 0.837. Number 5. 43% of marriages end in divorce. You randomly select 15 married couples. Find the probability exactly 5 of the marriages will end in divorce. So this is an example of a binomial probability distribution. We know that a probability experiment is considered binomial if the following happens. We have a fixed number of trials. So in this case, we're talking about selecting exactly 15 couples. So in this case, N is 15. And those trials are independent. So we have independence, meaning that the probability that someone else's marriage ends in divorce is not necessarily affecting the probability that my marriage will end in divorce. So we have a fixed number of trials, and all of those trials are independent of each other. We also have only 2 outcomes, what we call success and failure. Right? So like shooting a hoop in basketball. Either you make it or you don't. There's really no other option. So here, either you stay married or you get a divorce. There's not really any in between. So there is only 2 outcomes here, and those outcomes in terms of probabilities are also fixed. So here, the probability that you end in divorce, P, the probability of that happening is 0.43. The probability that it doesn't happen is Q, and that's 1 minus the probability it will happen, right? Because that's the only other option, so that would be 0.57. Okay, so those are our 2 outcomes for this probability experiment. The probability that exactly 5 of the marriages will end in divorce, we could do this by hand using the binomial formula. It looks something like this. The probability of having X number of successes is equal to a combination N choose X times the probability of success raised to the power of X times the probability of failure raised to the complement N minus X. So we could do this by hand and fill in our combinations, our probability of success and our probability of failure by hand. Or we could let the calculator do the work for us. So there is a binomial function on the calculator. It's in the distributions menu. And the inputs look something like this. Binom PDF of NPX. So N is again the number of trials, P is the probability of success, and X is equal to the number of quote successes that you want. In this case, we're looking for the probability of 5 marriages ending in divorce. So this is our value of X in this case. So here's how you find it on the calculator. Let's clear this out here. You're going to hit the second button and then the variables button. That gets you into what's called the distribution menu. And you want to use the down arrow key and scroll down until you see binom PDF, so the binomial probability density function. There it is right there. Hit enter to select it. If you have a newer calculator, it'll take you to a menu where you just fill in these things and hit calculate or enter or something like that. The older calculator, like what I have, you have to enter these things in using the comma button. So I have to enter 15, comma, right next to the parenthesis symbols here. P, our probability of success is 0.43, comma, our number of successes that we want is 5. Then close parentheses and hit enter. So the probability that exactly 5 marriages will end in divorce, 0.1598, is going to round that second digit up to a 6. So our value here is going to be A, 0.160. Number 6. same situation here, 43% of marriages end in divorce. You randomly select 15 married couples. Find the mean number of marriages that will end in divorce. So in this case, we're looking for the average of a binomial distribution. The formula in these types of situations is super easy. The mean is just n times p. So we're looking for the number of trials here again, 15, times the probability of, quote, success, which in this case is the probability it ends in divorce, 43%. 15 times 0.43, which is 6.45. Now, in reality, we probably really should round that up to approximately 7 because you can't have 0.45 of a marriage ending in divorce, but that's going to be our arithmetic average. Number 7. A fair die is rolled until a 2 appears. Find the probability that the first 2 appears on the 5th roll of the die. The wording of these types of problems is really your biggest clue. As soon as you see this, find the probability that the first something, like the first success, whenever the first something appears on a certain trial number, as soon as you read that type of wording in a problem, you know it's talking about a geometric distribution. Whenever the first success occurs on a certain trial number. So the geometric probability distribution reads something like this. Probability of success is equal to P times Q to the x minus 1. Okay. So in this case, probability of success is rolling a 2. Well, on a fair die, a 6-sided die, the probability that you roll a 2 is 1/6. That's P. The probability that you don't roll a 2 is that you roll a 1, a 3, a 4, a 5, or a 6, and that's all the other numbers, so that's 5/6. So that's the probability of failure, and we're going to raise this to the x minus 1. Now, x is the trial number that you want your first success to be on. So in this case, we're looking for the first 2 to appear on the 5th roll. So this is our value of x, the 5th trial. So I'm going to raise 5/6 to the x minus 1, 5 minus 1, which is 4. Okay. So we're going to plug this in, 1/6 times 5/6 to the 4th power, and that's 0.0803, so 0.080, that's going to be D. Number 8, the mean number of customers arriving at a bank during a 15-minute period is 10. Find the probability that exactly 8 customers will arrive at the bank during a 15-minute period. As soon as you're asked to find the probability of something happening during a certain interval, usually it's going to be an interval of time, you know right away that this is going to be a Poisson distribution. So a Poisson distribution's formula looks something like this. Probability of x being the ratio of the mean raised to the power of x times e raised to the power of negative mu all over x factorial. Now this formula looks kind of intimidating, but again, we can do this in the calculator very simply just by plugging and chugging. So I'm going to write down all the information that I have given to me in the problem. The mean number of customers arriving at a bank during a 15-minute period is 10. The mean is 10. That's mu. Find the probability that exactly 8 customers, well, that's x. That's the number of successes that I want, so I'm going to raise it to the power of 8. Find the probability that exactly 8 customers will arrive at the bank during a 15-minute period. E here is the irrational number e. It's not a variable. You're not plugging anything in for that, and I'll show you where to find it on the calculator in a minute. E is going to be raised to the negative 10th power. And we're going to divide this by 8 factorial. This symbol here, the factorial symbol, just means a product of every number with the number less than it. So for example, 5 factorial means 5 times 4 times 3 times 2 times 1. The bigger the number is, obviously you don't want to do that by hand, so again I want to show you a shortcut for doing that in the calculator. I'm going to plug this whole thing in at once. to get my solution. Okay, so let's clear this out. In the numerator, I'm going to open a set of parentheses because I want this whole operation, 10 to the 8th power, e to the negative 10th power, I want that whole operation to stay in the numerator, so I'm going to put parentheses around it. 10 to the power of 8 times e. Now the e, the irrational number e, is right above the natural log button. So you can see it down here. The natural log button is 3 from the bottom on the left-hand side, ln. You can see little e to the x there. So hit your shift key, second button, ln, that gives you the e. And then negative 10, don't use the subtraction sign. There's actually a negative key on your keyboard here. Negative 10. Close the parentheses for your exponent. Close the parentheses for the operations in the numerator. Then we're going to divide this by 8 factorial. We press 8, and then to get the factorial symbol, it's back in the probability menu from the last video. Math button, scroll over to the probability menu, PRB, and then it's the 4th one down. See the little exclamation point. Hit enter. So 0.11259, that's going to round to 0.1126, so it's going to be B. Okay. And that is all the problems I have for you for Chapter 4. Mainly work on knowing how to read a probability distribution, work on being able to recognize binomial distributions and finding probabilities in a binomial distribution, the mean and the standard deviation formulas for probability distributions, and then the difference between Poisson and geometric problems. That's pretty much going to be the bulk of the concepts that will appear on exams involving Chapter 4 questions. So again, let me know if you need anything, and that concludes our Chapter 4 review.